Okay, let us discuss this problem. So this says a flywheel with initial angular velocity omega naught. So there is a flywheel that has initial angular velocity omega naught. So let us say this flywheel is rotating about this axis passing through this line. So this has a initial angular velocity omega naught. Decelerate due to the forces whose moment related to the axis is proportional to a square root of angular velocity. So there are some movement that is acting. So there is a force, let us say, and this force will apply a moment about center. So this is center. So this moment will try to decrease omega naught. So there is a torque of force. Now question says moment of this force, so that is torque, is proportional to a square root of angular velocity omega. So I can say this implies torque is equals to, and this is basically deceleration. So I can say this is minus under root k into omega, because torque is acting in the opposite direction. So I can say torque is equals to minus k under root omega. Why I am writing minus? Because this torque is doing deceleration. So when I will write torque is equals to I alpha, and in that equation torque will be negative because torque is decelerating. So this is a decelerating torque. So this is a decelerating torque. So this is a decelerating torque. Are you getting? Now torque is proportional to k under root omega, and torque can be written as I alpha. So I can write minus k under root omega is equals to I alpha, and alpha can be also written as d omega by dt. Are you getting? So let us say keep I as it is, and the last I can eliminate this I, because moment of inertia of flywheel is not given. So let us assume I for this is mr square by 2. Even if I assume I, in the last it will goes to cancel out. So we will have minus k by I dt is equals to d omega. Now if I integrate this, d omega by root omega, if I integrate from 0 to time t, and this is initial velocity, angular velocity omega naught to omega. So what we will have? So we will have minus k by I into t, and this is root omega will be omega to the power minus 1 by 2. So this will be omega to the power 1 by 2, 1 by 2. So this is 2 under root omega. Under root omega will be given as under root omega minus under root omega naught. So this is the, you can verify yourself. There is no mathematics here. This is simple integration. Are you getting? So if you do, so you will have for omega, you can write for omega under root omega, this will be given as under root omega naught plus or minus kt by 2i. So this will be under root omega. Now if you square, you can get omega. So omega will be a square, this square, this square. So let us say under root omega naught minus kt by 2i raised to the power 2. So this is my omega. Now question says find out the average angular velocity. So question is asking find out the average angular velocity averaged over total deceleration time. So I have to find total deceleration time, that the final omega will be 0. So when this total deceleration time, this means final omega will be 0 when this system will stop. So from there I can find time. So when omega is equals to 0, that the flywheel stops, t is equals to t naught. So if I solve for t naught, what will you have? So 0 is equals to under root omega naught minus kt naught by 2I raised to the power 2. Are you getting? So this will be, T naught will be 2I under root omega naught by k. Now I have to find average angular velocity. Let us call average angular velocity is written by this sign. So this is average angular velocity. So this will be given as total distance by total time, that is omega into dt. This will give you total theta divided by dt, that will give you total time. So this is the integration we have to solve. And time will go from 0 to t naught. So this goes from 0 to t naught. So the lower integration is easy. Upper one is slightly difficult. So let us try to do upper integration 0 to t naught. Omega is given by this expression. So you can use this expression or you can use this expression. So omega is given by under root omega naught minus kt by 2I whole square. So this is omega square dt. So let us first calculate the top integration. So we will have numerator integration. I can call this as a I1 and I can call this as a I2. So if I do this one, so what we will have, omega naught plus k square t square by 2I, so that is 4I square, minus 2 under root omega naught kt by 2I into dt, 0 to t naught. Let us try to integrate this. So this will be omega naught t naught plus this will be tq by 3, so k square t naught q by 4 into 3, 12I square. Are you getting? Minus, we will have here t square by 2. So this 2 is already cancelled. So we will have under root omega naught k t naught square by 2I. Are you getting or not? So this will give you the integration, the numerator integration, and I2 will be simply, that is dt, that will be equals to t naught. So if I do I1 by I2, t naught cancels out. So you will have here omega naught plus k square t naught square divided by 12I square minus, so t naught goes under root omega naught k t naught by 2I. Are you getting? So let us copy this one. And now if we plug the value of t naught square, so t naught square is what? So you see t naught is, here I have this value 2I under root omega naught by k, 2I under root omega naught by k. So this is my t naught. So if I plug the value of t naught, what I will have, so the first term is simply omega naught and the second term will be k square by 12I square into t square will be 4I square omega naught by k square, and minus you will have under root omega naught k by 2I into t naught is 2I under root omega naught by k. Are you getting or not? So this is, this k square cancels out, I square cancels out. So we will have omega naught plus 4 omega naught minus, this goes omega naught 2I k. So this is minus omega naught. Are you getting? And here I will have 12 also. So this goes, omega naught goes, so I will have omega naught by 3. So in this case, average angular velocity will be omega naught by 3. You see, in this problem, only concept we have learned is normal reaction is given by minus k and root omega. So how to integrate this and find omega at any point of time? So for any t, how to find omega? To find average angular velocity, so what I need is total theta, that is the total distance, that is theta by time. And theta can also be written as omega dt, and time can also be written as omega d. So this is the average angular velocity. Are you getting? So if I use this, I can finally get the average angular velocity will be omega naught by 3. And this is a pretty easy problem. You have to only put the value of t naught and do integration, you will get the final result. Now we will discussing the next problem. So this is an easy problem. Are you getting or not? Because normal reaction is at a torque that is proportional to under root omega, and from there you can find what should be the time after which the omega goes to 0. That this means the final omega is equals to 0 when t is equals to t naught. So from there we can solve for t naught. And then if I use that t naught in finding the average, omega dt integral 0 to t naught divided by integral dt 0 to t naught will find the value omega naught by 3. Let us discuss the next problem.